Hello, students, YouTube learners. This is Dr. Satish Singhal, PhD, Professor Computer Science at Camino College, Torrance, California. This is the last video, video 505 on design example 4, pizza cost calculation and order processing. In this part, last part, we are going to develop source code, which is based on this algorithm that we have done in the part 4. And we are only going to show you key portions of it. We don't really need to show you everything like user input, flag setting. That's actually so clear from algorithm that you can easily understand it, although we'll show you the coding parts of it. But most important we want to show you is the nested if and else part and standalone if parts. To compute the cost, like compute the base cost, this algorithm was used. Flower increment, this algorithm was used, and so on. And we already have source code written in Xcode. Let's view that first. And since I'm here, I'm just going to copy and paste that so that I can paste that in relevant portion of source code temporarily and show you the correspondence between the two. At some point, you'll get so used to reading source code that you will very quickly understand algorithm from the source code and source code from the algorithm. That's the art of reading source code. And yeah, if somebody asks you to do source code, you can do source code very quickly then. And if they ask you to do algorithm, you can do algorithm very quickly. So let's go to Xcode. Xcode is another piece of software that works like Visual Studio. So first let's review the whole code. So the reason I'm going to need string is because I'm asking their name. I have many because I'm printing the raw cost. Although in this case, raw cost is not going to have a fractional penny because anywhere I've not used all the multipliers more than 2 decimal point. If I use 3 or 4, then that would be a different situation. But still, our procedure, we need to learn our procedure to find whole dollars and cents from the raw cost. Okay, this you can set precision to anything, doesn't matter because we are only displaying that to display the raw cost because we are converting to whole dollars and whole cents. Our variable declaration, name input, saying hello to them, getting the size code, and notice how we have done that. We say please enter the pizza size small, so whatever letter they should enter, we put that under bracket, and that means they should enter uppercase S, uppercase M for medium, large pizza, uppercase L, X for extra large, and we take input, and just in case they made an error in entering lowercase letter, we use the toUpper function to transform user input to uppercase. So what does toUpper do? What toUpper does is that if they enter a lowercase letter, toUpper function converts that to uppercase and returns it and stores it back into the code. But if they enter uppercase, it doesn't do anything. It just returns the same one. And then we have the flag setting. This has been described already twice. And then we get input for the flour. And then we tell them 0 for white flour, 1 for whole wheat, and etc. etc. And we take the input for the flour code and we set the flour flag. And then we want the cheese. We use the same technique for the character inputs. Whatever we want, we put that inside square bracket. So R for regular cheese, E for extra cheese, and so on. This is a very good technique. You don't have to write a separate little statement for that, that enter J for jalapeno. You can just integrate the name and the letter they should be entering in the same word. And user input is taken here, and then we convert in case they enter lowercase to uppercase. And we set the cheese flag cheese code, and then the topping 1 to 5, 0 to 5, and we set the flag for topping code comparing user entry to either 0, 1, 2, 3, 4, or 5. So if they entered 0, 1, 2, 3, 4, 5, this flag will set to true. And finally we get to the cost computation, which we should only be doing if all flags are true, because otherwise one of the user input was not something that will allow us to compute cost. So if flag base code, flag flour code, flag cheese code, flag topping code are all true, joined by an expression and an operator, then we can do the cost computations. So let me copy and paste the sorry, algorithm that we wrote. That's right here. Okay, I don't know what happened here. Okay, somehow. Let me go back to my document again, Word document. And so it's actually pretty simple. You have seen that already in lab 3. We start out with if, everything is lowercase, and I could set it to 0 or not. In this case, it wouldn't matter. Just variable initialization. But 19.11 was this. So how do we code that in the source code? We use the lowercase if, this condition, and this condition remains the same. We don't use the word then in the source code. Rather, we use the left curly brace. And this expression and this expression is same, except, as you know, each program statement should terminate in semicolon. So rest of them are coded the same way. Okay. So you can just learn this rule, how to convert from algorithm to source code. Then we do flour increment. So let me go and copy and paste that one. That's this one here. In algorithm, we kind of leave issue of variable initialization hanging up in the air, because it's understood that somehow you will initialize it when you do the source code to prevent the logical errors. If that makes you uncomfortable, then you could, if you want, initialize them in the algorithm as well. Personally, algorithm is a kind of approximate map. It doesn't have to be completely 100% exact like source code, but whatever makes you feel comfortable in the algorithm to add a few more details, you can certainly do that. But to me, those are minor points. Okay, so we set the flour increment to 0, and this is our algorithm. If flour code is equals 1, then increment of flour is, and again I used base cost into 0.02. Here in algorithm I said 2.0 into base cost by 100. This means the same thing, because 2 gets divided by 100 is 0.02. So you're not going to see me totally consistent in this case. But one more time, why did I have to do else if here? Because we left out flower code 0, which was the increment would be 0 in that case, which I already set. So I don't have to actually test for 0. I already set that to 0. So if user enters flower code 0, notice 1, 2, 3, none of these will execute because I use the else if. But if I remove that, then there will be a bug in the program, because for flower code 0, this case will execute, and for 3 also it will be executing. So as I point out in the algorithm, that's why we do else if here, because we left out the flower code 0 case. Okay. And you can take this copy of the source code, which I'll be uploading, and copy and paste from the algorithm into the source code and check how we have done the conversion. So I am not going to go through the rest of it. You can work this by yourself. And then we get the total cost, print the raw cost. That's going to come out same as we do dollars and cents, convert to dollars and cents, and output it. And then rest is, again, we explained in the algorithm that else block will execute when one or more of these flags are false. And that means user entry was something that was an error that would not allow us to process the pizza order. In that case, else block executes, and there we check the negation of each of the flags. Whichever one was false, negation of that will become true, and we output the error message relevant to that. And once again, I do understand you guys are on the learning curve, so you need to hear certain things again and again and again and again. And I used to be such that, okay, why do I have to say something so many times? But I understand you're on learning curve, so you need to hear it again and again. The reason we don't use nested if and else here, because there's no way you could make user entry such that they will only make one of the 4 input errors. That's humanly impossible. They can make one entry error, 2 errors, 3 errors, or all 4. And doing nested if and else here would mean they can only make one error, which is humanly impossible for a programmer to control. So you have to check in each case. This is the case where only if can be used, standalone if, as many times as we check. Nested if and else is completely 100% wrong in this case. And if you are not convinced about that, think about it. You'll come up with the correct code. Because we cannot control user to make only one error out of 4. They could make 1 error, 2 error, 3 error, 4 error, 5 error. Okay? So standalone if is the only way to build correct software in this case when we are outputting error messages. Okay, final thing, we'll just run it and show you the output. I've done this before, so I think we are still seeing some output from there. And you can do some calculation by hand by yourself. I will not do that. Let's run it. Okay, first name only, Sam. So it's telling us we'll take your order and process it. Enter pizza size, small, medium, large, or extra large. So we're gonna go with M. And even if I enter lowercase m, that'll work because I use the toUpper function to convert lower to uppercase. We would like to know what kind of flour you would like in pizza crust, 0 for white flour crust, 1 for whole wheat, 2 for organic, 3 for multigrain. So we'll go for organic whole wheat. We would like to know your pizza cheese preference, regular cheese, extra cheese, jalapeno, or goat. So we'll go with jalapeno. And 0 for no topping, 1 for mushroom, 2 for shrimp, 3 for organic, etc. Well, we'll go for all 5. And in this case, just so happened because all my multipliers were only 2 decimal place, you got the raw cost converting dollars and cents to be the same thing. Okay, so that's the source code conversion from algorithm, source code itself, and execution. So we are going to, of course, we are uploading 5 videos, but we'll upload this document as well as this source code. You should run the source code by yourself. Okay, although you don't have to type it, but you should run it actually. All right, so this was the last video in series of 5, and on source code, this is Dr. Satish Singhal, PhD, Professor of Computer Science at Community College Torrance, saying goodbye to you from this video. Pretty soon I'll see you in videos on looping, repetition control structure. Thank you.